Okay, so I want to tell you what is often the second step if just plugging in the value doesn't work to evaluate the limit. So let's consider this limit. The limit as x approaches 3 of x squared minus 4x plus 3 divided by x minus 3. So the first step is, let's see, like, is this function continuous at x equals 3? Could we just plug it in? And you can see that 3 is not in the domain of this function. So it's it's not continuous at x equals 3. And you can also see that, like, the numerator is going to 3 squared minus 12 plus 3, so that's 0. And the denominator is also going to 3 minus 3, which is 0, right? So the fraction is going to 0 over 0. And in our worksheet, we sort of saw that this means, like, anything could happen. We don't know what's going to happen. So we need to evaluate this limit by using algebra. So we're going to use what's often the second step, and that's factoring and canceling. So we're going to factor the top. You can write x squared minus 4x plus 3 as a product of x minus 3 and x plus 1. So x minus 3 times x plus 1. And you can see these are the same by just foiling. X minus 3 times x minus 1 times x minus 1. So we can see these are the same by just foiling. And now I'm still dividing by x minus 3. So I haven't changed anything because I've just rewritten the limit. I've just rewritten the function. But now you can see that there's an x minus 3 on top and an x minus 3 on the bottom. And so so what's happening is at x equals 3, this function is not defined. 3 is not in the domain of this function because I would be dividing by 0. But everywhere else, besides x equals 3, I can cancel this out, and now I'm looking at the same function. And so I can cancel this in the limit because we don't care what happens actually at x equals 3. It's irrelevant to what the limit is. And so since the functions are the same everywhere else, then if I'm evaluating this limit, then I can do this cancellation. So this is the limit as x approaches 3 of x minus 1. And now this is a continuous function. So now to evaluate this limit, I can just do the first step, which is just plug in x equals 3. So this is equal to 2. And so using factoring and simplifying, in the beginning, I wasn't sure what the limit was. I wasn't able to plug in. It's going to something tending to 0 over something tending to 0. But now with the simplification, it's a limit that I can just evaluate.